Apple wants AI to run directly on iPhone instead of in the cloud. Apple releases paper tackling running large models on phone memory. In recent news, Apple has unveiled a paper outlining a method to run large language models LLM on devices surpassing the available DRAM capacity by significantly enhancing memory usage efficiency. This breakthrough research supports running LLMs twice the size of available memory on devices with limited capacity, resulting in a substantial boost in GPU inference speed. The paper points out that the intensive computation and memory requirements of LLM pose a significant challenge for DRAM capacity. The paper introduces a flash-based inference cost model, optimizing in two key areas: reducing the data transferred from flash and more efficiently reading data blocks. This innovative research expands the applicability and accessibility of LLM, potentially hastening Apple's plans to integrate generative AI into iOS 18. Generally, DRAM refers to what we commonly call memory, while flash refers to the hard disk. During calculations, the CPU usually uses DRAM as an intermediary bridge to copy data from the hard disk to memory, then processes the data in memory, increasing speed by millions of times. However, in terms of capacity, DRAM is an order of magnitude smaller than the hard disk. During LLM runtime, the substantial amount of data that needs simultaneous processing poses a significant challenge for devices with limited capacity. The paper introduces a new framework that appears to have found a breakthrough. The framework aims to store model parameters in flash and bring data into DRAM only when needed, addressing the challenge of LLM runtime data processing exceeding the available DRAM capacity. Specifically, Apple employs two main techniques. One, windowing technique, repeatedly using previously activated neurons to reduce data transfer. Two, row-column bundling technique, customizing the order of accessing data blocks for flash based on data characteristics, thereby increasing the size of data blocks read from flash. The paper mentions that a model with 7 billion parameters requires over 14 of memory to load parameters in half-precision floating point format, exceeding the capacity of most network endpoints. However, through this framework, it is possible to minimize data transfer and maximize flash throughput, thereby reducing data payload and improving memory usage efficiency. The research results indicate that compared to traditional loading methods, this framework supports models twice the size of DRAM, with inference speed improvements of 4 or 5 times on CPU and 20-25 times on GPU, the research team concludes at the end of the paper. This breakthrough technology is particularly important for deploying advanced LLMs in resource-limited environments, thereby expanding the applicability and accessibility of LLM. In the era of AI, major smartphone manufacturers are actively venturing into artificial intelligence plus smartphone. According to previous market reports, Apple will introduce AI in its iOS 18, primarily for intelligent question and answer features, sentence generation, etc., in Siri and communication applications. Additionally, Apple is exploring the potential of AI in applications such as Apple Music. Samsung launched its generative AI model, Samsung Gauss, in early November, with reports suggesting its integration into the upcoming Galaxy S24 series smartphones in early 2024. Samsung's laptops and tablets may also integrate this model. Google's Gemini, a large model, will be integrated into various Google products. In November, Google officially announced the gradual rollout of Gemini 1.0 in Google products. Gemini Pro will be integrated into Bard for advanced inference and planning, while Gemini Nano will support the features of the Pixel 8 Pro smartphone.